midpoint of a line segment. So suppose I wanted the slope of the line that connects 2 points A and B. In this case, -8, -3, and 4, 6. So the first thing that I would do is I could either use the step pattern on the graph to calculate that slope, where I use the rise divided by the run. Or we could use this equation, m is equal to y2 minus y1 over x2 minus x1. Suppose I take a look at the equation of the line that connects them. The key idea would be to simply, first of all, start with y equals mx plus b. You have your slope that we calculated from before, but then we need one of the points, either A or B, and substitute into the equation and solve for B. Or what we could do is read that stuff directly off the graph. Now, graphs aren't necessarily accurate, so be very wary of them. Now, let's say that I needed you to calculate the slope of a line perpendicular to the line that connects them. So if I needed to calculate that, what I do is I, first of all, calculate the slope of the line between those 2 points. Then what I use in order to find the perpendicular is I use the negative reciprocal to call, and we're going to call that m upside down t. And in mathematics, we refer to that as m per. Okay? It's read as m per. Suppose I need to calculate the midpoint between 2 points. So if I needed to calculate the midpoint between 2 points, what I have to do is I have to average or walk to the middle of those 2 points by either using half of the run and half of the rise and adding it to the first point of my line segment, or start from the end point and subtract those half of the run and half of the rise on each of the components of the point. Now, if I wanted to find the equation of a line that's perpendicular to a line that goes through its midpoint, first of all, you find the m per from the original m, and then you use the point that we talked about, which is thus the midpoint. Now, today's lesson is about finding the midpoint of a line. Basically, there's 2 methods to find it. You use this one right here, which is basically taking the original point, say x1, which is A2, 5, and then adding half of the rise and half of the run to both respective x and y quantities. Now you could also go from the end point and subtract half the rise and half the run to get to the midpoint. Now I would tell you that you can use this as a fact, but I would say that it's just too cumbersome. Just keep this in your tool bag in order for you to find, say, endpoints or midpoints using these properties. Sometimes you might see them when you're dealing with radius calculations, because the diameter is twice that. So you basically have half the rise and half the run, and you're adding or subtracting it to a... Overall speaking, if you think about the most commonly used version of the midpoint, is basically you just average the x's and the y's of 2 points A and B. That's all they are. And we'll use this equation to decrypt it, to describe it. And now let's discuss what a median, right bisector, and an altitude is. So when you talk about a median is basically one side of your triangle that's split in 2. And if it's split in 2, that means we have a middle point between the endpoints, right? And we call that the midpoint of the line segment. And what we do from the midpoint of the line segment is we connect to the opposite corner of your triangle, and that is what we call a median. When we talk about a right bisector literally does this. It splits the side it splits the side in 2 that it's working with, but then the line that connects from the midpoint to the opposite corner is going to be at a right angle. Now, when we talk of an altitude, we've talked about that before. It's just a line that's a right angle to the base. But notice it's not necessarily that point that connects the right angle to the base is not necessarily splitting your base of your triangle or side of your triangle into two equal spots. So we still call it an altitude. Now, if you think about it, you need to know what kind of circumstances a median or a right bisector being the same thing. That only really happens when you have an isosceles triangle or an equilateral triangle. And the same can be said about the circumstances where the median, the right bisector, and the altitude have the same thing. That's when you have an equilateral triangle or an isosceles triangle being created from the top corner of your triangle.